Okay, hi guys. Sorry for my voice. I'm a little bit ill. I'm going to be talking about Hurricane Helen, not to be confused with Hurricane Florence, which is currently posing a threat to the Carolinas in the US. I'm concentrating on Hurricane Helen because it's a really interesting storm. Because in many ways, quite similar to a Hurricane Ophelia last year. Actually, a tropical cyclone that potentially could make a European landfall and maybe can even survive to the UK still intact as a tropical system. I mean, this would be the first time this has ever happened, with the possible exception of Hurricane Debbie in 1961, but that's an unverified case. But regardless, this would be a truly historic event if it happened. By historic, I don't mean in terms of severity. I mean, it could be quite a severe storm, but we're talking yellow or possibly amber metal risk warning level of severity. The really interesting thing about this is not the severity of the storm, it's the meteorological history that would be made to have a tropical system, even a really weak one, actually hitting the UK while intact as a tropical system. And like I said, this has never happened before. It's happened in Europe once, which was arguably twice actually. Once Hurricane Vince landfalled in Portugal as a tropical depression, and also there's two other cases that are possible. There's also Hurricane Faith, which hit the Faroe Islands, and there's Hurricane Debbie, which I mentioned, which may have hit Ireland. These two cases are unverified though, so there's only one actual case of this happening in Europe. And again, last year we made a good attempt to try and have a second case with Ophelia, but Ophelia, when it did hit the UK last year, didn't do so as a tropical system. It did so as a recently ex-tropical system. So we're going to look into this again. There have been many cases of tropical systems that have got close to the European continent, but none that have actually landfall. Anyway, enough of that. Let's talk about Helen. So this is a satellite image of what Helen currently looks like. It's a really weak storm. Actually, I believe it's no longer even a hurricane. I think it may be a tropical storm, which is sort of less than 74 miles per hour maximum wind speeds. I think more than 39 miles per hour sustained maximum wind speeds. So it's quite a weak storm, and you can see that it's quite a sheared storm as well. The circulation center is actually to the south of the convection that's still around. So this is definitely a weakening storm. The reason I'm interested in such a system, despite the fact it's weakening, I mean, as opposed to Ophelia, which strengthened as it moved further north, getting to a category 3 at one point. The reason I'm interested in this tropical storm is that the models are actually showing that it could strengthen up again, but not in a baroclinic way, not in the sense that it will become a strong post-tropical storm, but actually we could get some tropical intensification. This is not guaranteed. And in fact, actually, NOAA forecasters are suggesting that we're going to see a continuation of gradual weakening. That being said, a lot of the models are going for intensification. So I kind of think, well, the reason that the NOAA scientists are probably suggesting that it's going to weaken is the unusual sort of position that the storm is in, and the relatively high wind shear. But since the models are going for it, the possibility cannot be dismissed. So I do want to talk about this. Okay, so let's have a look at the models. Let's start with a simple one. Let's start with the GFS. So I've put this on theta E, which is equivalent potential temperature. So the reds are warmer, moister air, and the blues are cooler, drier air. You can see that this is an example of an ex-tropical storm. It's got an asymmetric structure. It's got a warm sector, and it's got a cold sector. This is what an ex-tropical storm has. It looks like it has fronts, and you can also see that the actual structure of the isobars is quite asymmetric as well. Tropical cyclones are very symmetric. So we roll this forward, and you can see this is tropical storm Helen, and you can see what I mean by how symmetric the system is. There's no cold air surrounding it. It looks basically the same on all sides. This is definitely a tropical system. So we run it through, and we can see that we've got the latitude of Spain here by sort of Sunday, early in the morning. And you can still see this is very much still a tropical system. Again, you can compare it to these two ex-tropical systems here, and another one here, I suppose. They all look quite different in structure. This is still definitely tropical. So let's run it forward a little bit more. So now we're at the latitude of Spain, and we can actually see there's some degree of tropical intensification here. So it's actually starting to intensify. It's still tropical. It's completely surrounded in this envelope of warm, moist air. there's no well-defined warm or cold sector, so this would still be considered a fully tropical system. It's the same latitude as Spain. This is remarkable in of itself. Let's roll it forward a little bit. By the time we get to early morning on Tuesday, this is still more or less tropical. I suspect we've started to get some baroclinic, by baroclinic I mean the non-tropical effects, the effects of different air masses coming into play at this stage. But it's still mostly tropical, albeit somewhat weaker than it was. This is still probably tropical storm strength though. We can see that there's a cold front kind of here that's sort of encroaching towards the tropical cyclone, rather similar to Hurricane Helene last year actually, which was sort of torn up by a cold front. But at this point it's still tropical. So that's 108 hours. This is early on Tuesday. So Tuesday, sort of midday, this is a storm that is now beginning to undergo post-tropical transition towards a depression. It's still tropical, but it has undergone the transition. In official meteorological terms, a storm that is halfway between baroclinic depression and a barotropic tropical system would still be considered to be a tropical system just by the way it's defined. So in order for this to hit the UK, you wouldn't actually need it to be completely 100% tropical. You just need it to be not 100% atropical in a sense. So as long as if the tropical transition has started, which at this point it has started, but it hasn't finished, then it would still be considered to be a tropical storm. So at this point, it would still be a tropical storm, albeit one that has begun its transition towards an extratropical storm. You can still see it's mostly symmetric, but you can see that there is somewhat of a frontal structure. You can start to see that there's more warmer air to the south and to the east of the system, and more colder air to the north and the west. So we're beginning to undergo that extratropical transition by 120 hours. This point at later on Tuesday, it's nearly at the UK, and I think at this point we're really starting to lose those tropical features. The storm is no longer circular. It's developed this more elliptical type shape, and you can see that there's sort of a well-defined warm sector here. The tropical cyclone is still embedded within the warm sector, but the warm sector is becoming more prominent, and the sort of monopole of warm moist air associated with the tropical cyclone is becoming less prominent. So at this stage, I would still say it's tropical, but not only maybe 20 or 30% tropical at this point. And then by the time we get to 132, at this point, I would say this is completely extratropical at this point. So basically at the point that it makes landfall. So if it was to play out according to the GFS, we would not actually see it landfalling as a tropical system, but it's really close. I would say this is the point at which it would be considered extratropical. So we're still sort of northern France. So this would still be record breaking in terms of the furthest northeast a storm has ever managed to get while still being tropical. So still record breaking, but not quite a landfall, but very, very close. At this point, it's pretty much completed its transition, and then you can see we can play it further on, and you can see that it's just the warm sector is totally prominent. There's no sort of there's no symmetrical element to the storm at all. Okay, so GFS is kind of going for this extratropical transition to occur at a very high latitude, and it's going for an intensification. So the current situation of Helen is that even though it's weak now, we are going for some sort of tropical intensification, maybe to a stronger tropical storm, or even maybe a Category 1 hurricane, and then sort of a weakening and a transition to a extratropical storm by the time it gets to those sorts of latitudes. So I'm going to look at some of the hurricane models now. This is Tropical Tidbits website, so I can look at so let's have a look. I'll look at the parallel one because it's a little bit easier to see. So let's have a look. Oh no, that's Joyce. Sorry, Joyce is another high latitude storm, and I would be talking about this if there wasn't a more interesting one. Okay, Hurricane Helen. Well, former Hurricane Helen. So you can see at the moment, I suppose we're at about hour zero, and you can see that the central pressure is increasing. So the storm is beginning to decline in terms of intensity. So it's weakening, but then we see a situation where the storm, I guess the shear has maybe decreased a little bit, or maybe I think the sea surface temperatures are actually slightly warmer up here, sort of away from the cooler waters of the currents near North Africa. So I think the waters are actually slightly warmer here. But whatever the reason, there is some tropical intensification. You can see the pressure is starting to fall again. Incidentally, these northern latitude storms, you'll notice, are quite small. This is quite a standard feature of storms that manage to make it this far north. So I'm not surprised that this is a small system. They tend to be small because the Coriolis effect is stronger further north, so you can tend to get these sort of eye-like structures with a smaller storm, whereas further south you need bigger storms because the Coriolis force is weaker. So the size of these high latitude storms is not surprising, really. Anyway, we can see that the surface pressure is continuing to drop. I guess it's sort of stopped here, but you can see this is still a fully tropical system. You see it's got an eye wall structure, it's got light winds in the middle, it's got stronger winds around the eye wall, and it's very symmetrical. It's characteristic of a tropical cyclone. So let's what sort of time are we now? We're sort of going through, I think, into Sunday now. This is slightly less symmetric. You can see it's sort of stronger on its southern edge. So maybe we're starting to already undergo the tropical transition at this point. So this particular model seems to want to do it earlier than the GFS. It's still got some tropical characteristics at this point. You can still see it. There's still a lot of symmetrical nature to the storm, and it's still increasing in intensity. You can see the UK up here, Spain down here. Let's keep going. Okay, so we're starting to get a genuine tropical extratropical transition here. You can see that the storm is becoming a lot less symmetrical. Okay, so it transitions well before it hits the UK in this case. You can see probably around sort of here, and then we get quite a rapid transition. So this particular model is not wanting to do it so much. Let's have a look at the HMON, which is an interesting. This model is not coupled to the ocean, so it's not quite as accurate as the other one, but we can still have a look at it. Okay, so let's have a look. We've still got this period of intensification that's being predicted as it moves a little bit further north. Again, it's still quite symmetrical at this point. You can see that the wind field suddenly starts to expand. The expanding wind field is a sign of the transition. So when the wind field suddenly expands, that's a suggestion that it's undergoing transition. So again, this model wants to bring the transition quite early on. So these are fairly unexciting models. Now let's look at the ECMWF. So I've got the sea level pressure up here. We can sort of run it forward. I think we'll have to wait a few seconds before it actually appears. We can actually see it. Just bear with me. These are Central Standard Times or whatever, so ignore the sort of time on here because these are not GMT times. I'll try and speed this up a little bit. See if we can actually see Helen. Oh, I think we can just about see her now. Okay, here we are. Here she is. Okay, here we go. Okay, so it's quite obvious that this is the tropical cyclone Helen. You can see how symmetric she looks compared to all this stuff going on up here, which are extratropical storms. And you can see she's still intensifying. 973. Not a bad intensity, really. Okay. So I still think she's still probably a tropical cyclone at this point. 974, 975. So, maintaining its intensity. At this point, you can see that sort of there's a kind of cold front that's sort of sitting around about here. That's kind of pushing towards Hurricane Helene. So this will be weakening her because it will be bringing a lot of wind shear. So wind shear is essentially that the wind changes as you go upwards. Hurricanes do not like wind shear. You want to keep the wind shear as low as possible. You want to keep the wind basically doing the same thing as you go up. You don't want the wind direction or the wind speed to change. That rips these storms apart. Although coincidentally, it actually is exactly what you do want for ex-tropical cyclones. They love that sort of thing, but tropical cyclones hate it. So you can see there's a cold front sort of here that's sort of causing more wind shear around the storm. So the tropical transition has already begun, I would say, but it hasn't finished yet. So I would still this would still be considered to be a tropical cyclone. I would still say at this point it's still a tropical cyclone, but the transition has definitely begun, but not completed. And we're still at the latitude of France, where again we've already, if this plays out as suggested here, we've already broken records. We just haven't broken the record. Anyway, let's play this forward. I'd still say it's still just about tropical at this point. There's a sort of inner core area that is still very much tropical in nature, but the structure is definitely being eroded from the north and the west. And then we have landfall, or more or less landfall. It's very close. Maybe tropical here, ex-tropical here. I don't know. It's really close. So we can look at the thermal structure of the storm in any way. Let's have a look and see what parameters there are. Oh, we can have simulated satellite images. That might be interesting. Let's bring it back a little bit. Okay, let's have a look at the simulated satellite image. Okay, here we go. Here's a simulated satellite image. It's still a relatively weak storm. It's still a tropical cyclone, but you can see sort of the eye wall sort of here. Definitely tropical at this point. Sort of push this along. You can see sort of, again, you've got this sort of eye wall. You can see the eye just sort of showing here. It doesn't show it very well. And then also you can see this bank of cloud here is the baroclinic feature. So this would be your cold front or your frontal features. So this area is extratropical, whereas this area here is tropical. So you can kind of see the distinction between this bit being tropical and this bit being extratropical. And you can see what's happening is the extratropical part is beginning to erode on the tropical part. Okay, so it keeps going further north. I'd still say it's tropical at this point. You can still kind of see the eye sort of just here. Can we zoom in a little bit on that? Apparently we can't zoom in. We probably we can try and zoom in maybe later. Okay. It's difficult. I think you can see here it's kind of lost all its structure, but here there is still sort of some remnants of structure. I mean, you actually don't really need much of the tropical structure to still be intact for it to be considered a tropical cyclone. So as long as a little bit of it is still intact, it would still be considered that way. What's for sure is that we're not going to get to the UK while being completely tropical, but we might still get there as a tropical storm. Official, I mean, in a sense. Let's have a look at wind shear, because wind shear is the one that's important for sort of determining what's going to really rip these storms apart. Where's wind shear? If I type in, can I look for wind shear? Severe weather parameters. Oh, here we go. Let's have a look at low level shear. Actually, we want deep level shear, I guess. Okay, so there's going to be sort of colors around the actual storm itself. You don't really want to be looking at the actual storm because there's a shear associated with the storm itself, but that's not what actually destroys the tropical cyclone. You want the environmental shear, so the shear that's not associated with the storm itself. So, for example, all this stuff up here would be environmental shear. So what you want to watch for is that as the storm, you can see that the storm is getting close to the environmental shear. So you can kind of see the storm is about here. And at this point, you can see it's embedded in quite a low shear region. But the tropical transition will be noteworthy in the sense that it'll get closer and closer to the high level of shear. So you can see at this point, this is where the storm is. It's still just about in the low level shear, but you can see this band of high shear coming here. So when this shear starts to interact with the storm, it'll rapidly destroy it. So you can see now the storm is in this sort of wider area of quite high shear. Yeah, so you can see that by the time it landfalls to the UK, you've got this large band of shear, and the storm is kind of like it's not ridiculously large shear, but it's still enough to kill off the tropical storm. So you can see, as with what happened with Ophelia, you've got the storm that's initially in a low shear region that's sort of moving into a higher shear region. Okay, are there any other interesting parameters that we can look through here? I think I can look at wind speed. Wind speed might be quite interesting. Is there wind direction and wind speed? Okay, here we go. Okay, you can see the sort of eye as that region of sort of low wind speed. Like again, compare this here, which is extratropical, to this. You can see that this is a much more tightly bound symmetrical structure than this, which is clearly extratropical. Okay, so again, you can see that the storm is under attack from the northwest. You can see it's much more tightly bound on the towards the southeast, where the shear is lower. And again, you can see where the cold front is quite well here. You can see that the wind changes direction from sort of a northwesterly to a southerly wind here. So this is the cold front just about here, and the cold front is sort of to the north of the storm. And this is basically the same as with Ophelia. So still tropical at this point. And then you can see sort of just as it's about to hit the UK, it very rapidly degrades. So the structure becomes completely asymmetrical, and yeah, it totally disappears by this point. So you can see that it's undergone that transition just before it hits the UK. Okay, so what I'm going to do now, I think, is I'll bring that back and put it back on sea level pressure. Where's sea level pressure? I can't find it. And then I'll look at various ensembles. So of course, I'll put it probably to around here, and then we can see what the storm's doing on various ensembles. So that the ECM is not just one model; it runs a bunch of different perturbations, where the initial conditions are changed very slightly, and then the model runs them. And we can see what each of these different perturbations do. And if a lot of the perturbations agree on one particular scenario, you can kind of see that there's somewhat of an agreement. But if the perturbations are completely different from each other, then the uncertainty will be quite high. So these are all possible examples of what could happen. So what I'm going to find interesting is I haven't seen this particular suite of ensembles, but I'm going to flick through and see if I can find any examples of tropical landfalls with the ensembles. So this one was close, but maybe not quite. So let's have a look at some of the others. So let's just flick through them rapidly. So that one you can see is already definitely transitioned. So that's completely extratropical. So nothing there. This one is still going as tropical. Let's see how far that gets. Be interesting. Oh no, I think what I've done there. I think what's happening here is that the ensembles haven't quite loaded yet. So we're looking at a previous. Okay, so maybe we'll come back to these maybe in half an hour or so, because yeah, they haven't quite loaded. So the reason that there's that discontinuity is because we're looking at the previous suite. So yeah, haven't quite loaded that yet. Just going to the NOAA forecast for this storm, you can see that it's S means tropical storm. The black circle means it's tropical. The white circle means it's extratropical. So again, like I said, the NOAA forecasters are sort of they're expediting the sort of process to extratropical storm fairly quickly. But I think some of the models are suggesting it'll get quite a bit further than this before it fully transitions. In any case, it looks like the chance of it actually hitting the UK, whether or not it's tropical or whether or not it's extratropical, seems pretty likely. I wouldn't say very certain, because when I was looking at some of the ensembles of the past week, some of them hit France, some of them hit Spain, some of them missed the UK to the west, some of them sort of were absorbed into the extratropical thing and moved this way. But I'd say the majority of them do eventually hit the UK, but only a very small minority hit the UK while actually as a tropical system, which is what I'm interested in at the moment. While that loads, see if there's any other models I can have a quick look at. I haven't looked at the icon model yet, which might be quite interesting. Let's have a quick look at that. So let's go through. Here you can see him here. Sorry. This is an example of a transition that occurs quite a lot sooner. So you can see that she's more readily absorbed into this baroclinic environment. So the symmetricity is kind of very quickly lost. So I'd say that this is probably already completed, more or less. Yeah, I mean, you can see it's definitely completed by this point. So the icon seems quite keen to complete the transition fairly quickly. Let's have a look at the WRF model. This is a higher resolution model, so it should be interesting because the higher resolution models sometimes pick up on things that the lower resolution models don't pick up on. So let's have a look at the surface pressure. Where is that? I'm looking for it. That's really testing me on my GCSE French, I can tell you. Finally came in handy. Anyway, let's run this through. We're gonna have to wait a while till it sort of pops up. Oh, here we go. Here it's coming. There you can see it. You can see it down here. It's kind of obvious when it suddenly appears as this sort of black ball of death. Yeah, I mean, you can see how symmetrical that is. Yeah, really quite impressive system. And you see at 120 hours, you can see that it has degraded slightly. So if you look at this point, you can see that it's quite a big, the radius of symmetrical winds is quite a bit bigger here on both the south side and the north side. But if you look, say here, it's still quite symmetrical on the south side, but sort of you can see it's degrading from the north. But there's still sort of a small region here that would still be tropical. So we can get some clouds on that to see what it actually kind of looks like. So these are just cloud coverage. It's not simulated satellite, which would be ideal, but let's have a quick look at this anyway. Oh, here you can see this structure here is the storm. Okay, here we go. Here's the storm. That's not overly useful, but still You can see where it is anyway. And any other models which I haven't looked at. Is the parallel GFS still going? Huh. I know what I can do. I can look at the GFS ensembles. The ECM ones aren't ready yet, but the GFS ones should be. So I'm doing the same thing that I was trying to do with the ECM ensembles, looking at the different perturbations from the GFS, which also has. Sorry, I just got to blow my nose. Sorry about that. Which also has these different perturbations. So this is the operational one, which I already showed, which kind of undergoes tropical transition here and then becomes fully extratropical when it hits the UK. So let's run through some of the perturbations and look at the one which is most sort of interesting. Again, this one gets absorbed sort of, I'd say fully extratropical, sort of around here, but well before it hits the UK. So that one's not so interesting. Let's have a look at this one. Oh, that one just gets absorbed. That one kind of completely dies. See that would be a sort of very underwhelming scenario. Let's have a look at this one. This one goes further west, so I can't imagine it will. Yeah, completely absorbed. 3. Let's see. Well, this one got. Yeah, dissipates at sort of that. Well, it doesn't dissipate, but transitions at that sort of point. So most of them are not actually getting to the UK while tropical, but a lot of them are getting at least to the sort of French and definitely sort of Spanish latitudes. So we can still break records even if we don't landfall in the UK. With the record that I think we've got most chance of breaking is the most northeastern tropical system. I think that will probably go. I think the records that we will struggle to break is European landfall, because most of them don't seem to want to do it. See that one? So you can see here, tropical cyclone within a few hours, ex-tropical. So that one goes quite quickly. What we need is for the system to go further to the east, because the wind shear is lower in the east than it is in the west. So the ones that track further east, so this one I think is tracking a little bit further east. I think this one will survive a little bit longer. That's tracking well to the east, isn't it? Okay, it kind of sort of transitions before it makes landfall with Spain. So that one's sort of tropical there, but then it sort of transitions before it manages to make landfall. So no European landfall on any of them yet. Okay, this one's further to east as well, so more of a chance. That one's relatively close, but it's still quite a long way out. Let's go with this one. Nope, hang on. Yep, nope, nowhere near. Let's keep going. There's a few perturbations that want to take it south, aren't there? Seems like there's a chance that it could hit Spain. Oh, Portugal. No, this suite isn't as interesting as the 6Z, which had more. I mean, it didn't have any. The ECM 0Z this morning had a lot. Well, not a lot, but it had a handful that actually landfalled in the UK. So hopefully the ECM will be nearly finished soon, so we can look at that. But the GFS had a few that were closer. So this is. Oh, hang on, this one looks interesting. It's close. I'd say tropical there, ex-tropical there. That one's quite close. Definitely sort of French sort of latitudes. That one's quite close. Let's keep going. No. So you only need one of them to do it. Oh, hang on. What's this? Oh, that one's interesting. It's probably ex-tropical there, but maybe tropical there. That one's very close. So not a landfall, but we've actually got the system, while tropical, actually sort of influencing the UK. So not technically a landfall, but that one's the closest by far, I think. Yeah, that one's impressively close. Let's have a look. Keep going. No, that one, very unimpressive. Let's keep going. That one, I don't know what's going on with that one. Nope. Well, this one looks interesting, potentially. Another one that tries to go to Spain. But it's still, the ones that go further south don't seem to get further, they don't seem to get close to landfall. There seems to be sort of, the environment seems different, and the shear seems to sort of encroach on the storm regardless of whether it's moving at a more southerly latitude. So I guess the ones that you want are the ones that are sort of coming towards the UK, but go further east. You don't want the ones that are trying to go to Spain, because they seem to sort of die out. Or not die out, but transition. Let's have a look at this one. No, that transitions. You can see that that's a very rapid transition. Tropical there, extratropical there. Let's keep going. Yeah, that's transitioned. That's transitioned. Again, it's one of these southern ones. Okay, last one. No, not much interest there. So I think the one that came the closest, I think, was 14, did we say? No, was it 13? Was it 12? I think it was 12. Yeah, that's the most impressive one by far. Okay, so the GFS doesn't quite get there on this particular run. Let's have a look at the ECM, because the ECM, hopefully it's loaded by now. So maybe I'll refresh this. See if we can have a look with ECM. So this is, okay, let's keep going. Ugh, sorry. Okay, yeah, I think we're getting there now. Okay, so with the ECM, you can see that on this particular run, there's a small area of warm. Actually, one thing I could look at is cyclone phase spaces. I forgot to do that. Oh, we might look at that in a sec. So you can see that there's still a core region of sort of tropical structure, but by the time it gets to the UK, it's transitioned. But that one's fairly close. Okay, let's keep going through the ensembles. Okay, nothing there. Well, that one's already transitioned. That would be quite a severe storm, not in the sort of tropical sense, just in terms of like an extratropical storm. That would be quite severe. Doesn't look tropical though. Oh, you can see this one is one of the ones that's trying to go to Spain, isn't it? That one's interesting. Yeah, I would say that. Oh, that one there does constitute a landfall. Okay, first one we found that I think unambiguously is a landfall. So there was the operation one that we looked earlier. I thought that was possibly a landfall for the UK, but I think this is unambiguously a landfall. So there we go. There's our first European landfall ensemble. Yeah, I was thinking that we might not get an interesting one. Anyway, let's keep going. Ensemble 5, no, nothing there. 6, no. 7, no. Oh, hang on, that's an interesting one. Ensemble 8. Yeah, there's still sort of a that's an interesting one. Maybe still some tropical characteristics there. Okay, let's keep going. Oh, that's a French landfall there. Looks like it. Oh, there we go. There's a French landfall. That's unambiguously a French landfall. Yeah, so that would be record breaking as well. That would be the first ever French tropical cyclone. Yep, that's unambiguously a landfall. Okay, let's see what this one does. This one looks vaguely promising. I'd still say that's tropical. Huh. Well, it doesn't quite landfall. I'm not really sure whether that's baroclinic or barotropical. You can't really tell because the isobars are too tightly packed. So all you can really say about that one is it's a bloody strong storm. I think it's probably extratropical. I think probably here it's tropical, but it's probably extratropical before sort of that one doesn't even landfall anyway. But that one's a really strong storm. That one's already gone. Hang on, I might have a quick look at that though because it looks like it. Oh, there we go. There's a possible UK landfall one. Again, there's a very small amount of convection near the centre still probably. By the way, I'm inferring this from the structure of the isobars. I'd need to look through all the sort of thermal structure, ideally, but when you're flicking through ensemble, it's just easier to do this. That one's potentially a UK landfall. That one looks quite symmetric. Oh, there's one there, possibly. Not unambiguously, still sort of possible. Here we go. Here's another. Well, you can tell here that this is definitely tropical. Let's see what this one manages to do. Can we landfall in Spain or Portugal? Oh, there we go. I think that's a Spanish landfall. And that one looks quite strong as well. That could be a category 1 when it landfalls. Okay, so there we've got another European landfall there. That one's already gone. That one's gone. That one looks like it's transitioning quite rapidly. No, that one's gone before it hits the UK, but it still gets bloody close. And another one down here. The ECM is incidentally more, I would say, more reliable than the GFS. So, that's an interesting one. That doesn't seem to be really transitioning to an extratropical cyclone. It just tends to, it's just, okay, we can't go that far ahead. That just tends to be weakening. That's more like a Hurricane Vince style thing where it doesn't even transition, it just weakens. Interesting, nonetheless. Keep going. No, that one's gone. Actually, maybe might check it because it might have landfalled. No, that's extratropical. Let's keep going. This one down here. No, that's not going to get to the UK. That'll be. Oh, another southern one. You can see the wind field expands when it begins to transition. So that one's gone. Oh, this one looks like it could potentially. Yeah, that looks like another French landfall. That one's a maybe. No, that one's gone. That one's gone. Probably gone by the time it gets to the UK. Probably gone there, to be honest. That one's probably going as well. That one looks like it's quite close to France, but probably more or less gone. Yeah, there's a few. Even if we don't, there's a few that sort of stay down here, and even though they seem to struggle to actually get to Spain or Portugal, they are tropical in those sorts of latitudes. I think that the take-home message away from this sort of thing is that I think some record of some description is probably going to be broken. The easiest one, I think, to break would be the most northeastern tropical cyclone. The more difficult one to break would be some kind of European landfall. Actually, which country did Hurricane Vince? I think Tropical Depression Vince hit. Because I can't remember whether it was either Spain or Portugal. Because depending on which one it was, I suppose the other one has a chance of breaking a record there. So there's a possibility of that falling. Yeah, there's a few records that could fall. Oh, that one looks interesting. Let's go back. Still probably extratropical there. There's definitely a handful of interesting ones. I think a UK landfall as a tropical system is probably not likely, but it's more likely for Helen than. I mean, I'd say that the chance of a landfall. I mean, I was last year when we talked about Ophelia, I was basically making a video along these same sorts of lines, and I was going on with more or less the same discussion. I think this had, looking back to what I was thinking at the time versus Ophelia, what I'm thinking at the time versus this one. I think this one has more of a chance of doing it. Probably a slightly higher chance than that Ophelia did have of doing it. I don't think it quite will make it though. Yeah, so it'll be interesting to see. What I'm going to try and do now is maybe try and find some cyclone phase space diagrams. I can't believe I nearly forgot to do this actually. So bear with me while I try and find some of these. So cyclone phase space basically tells you whether or not the storm is tropical or not. Oh, hang on, can we even get one? Okay, operational. Let's look at GFS for now. Is this Hurricane Helen? Oh, here we go. I think this is Hurricane Helen. Oh, but it's literally like, oh no, this looks promising. Oh, okay, here we go. Got it. Sorry, I think I've turned the screen share off. Right, here we go. Cyclone phase space. So I'll just briefly explain what a cyclone phase space is. So cyclone phase space has two parameters. Well, actually, it has three parameters. You can see there's two phase spaces, so you need two to show three parameters. So there's the two thermal winds parameters, one upper, one lower. They basically determine the thermal structure of the storm. Tropical cyclones have warm cores, which basically means that they're weaker the further up you go and they're stronger at the surface. Extratropical storms are the way around. They get stronger the further up you go. And warm core in the sense that they are a sort of monopolar area, an anomaly of warm air. Whereas extratropical depressions are a monopole of cold air, albeit in the upper atmosphere. There are exceptions to that. There's the warm seclusion extratropical cyclone, which is warm core and also extratropical. We won't discuss warm seclusion because that's just going off the subject. The upshot is that a tropical cyclone can be defined with three parameters: lower level thermal, upper level thermal wind. So you want it to be warm core all the way up. So you want you want all the way up through the atmosphere. You want the intensity to be decreasing as you go up. If the intensity decreases in the first bit and then it starts increasing in the second bit, that would be warm core at the bottom, cold core at the top, and that would be a subtropical cyclone. But for a tropical cyclone, you need warm core all the way up. So hence you've got your lower level thermal wind here and your upper level thermal wind here. Second parameter, whether or not the storm is symmetric. This one's, I guess, more intuitive. If we're sort of close to zero or slightly negative, that means that the storm is symmetric. It doesn't have a warm sector. It doesn't have a cold sector. It's just, there's no angular dependence to the temperature of the storm. Asymmetric is frontal, so that's just like your bog standard tropical cyclone. Okay. Right, so this is our phase space now, and you can see that it started off down here. We were in the symmetric warm core area, and now we're sort of in this pink zone, which is your kind of subtropical region. So it's your sort of no, sorry. This is your region of some asymmetry, but still a warm core. But you can see the asymmetry is still quite low. We're still getting towards the red area. And this is where we are now. So GFS wants to continue to push the storm towards the cold core. So the GFS here is actually going for a relatively rapid transition to a cold core storm. But in terms of upper thermal winds, I guess it's going for that as well. I can't actually tell. Z is where it ends up, but I think can't tell if we're going sort of in this direction. But yeah, this one seems to go for a fairly speedy transition to extratropical in terms of the phase space. There are other models we can look at. Let's have a look at the UKMO. Okay, so this one here is slightly more interesting. So this is where we started out. This is where we are now. So we're tropical now, and then this is where we're going to go towards the UK. And you can see that we become slightly more asymmetrical, but we still maintain our warm core. So we're in this pink zone, which is sort of our undecided zone. So the transition has maybe started, but you can see that we don't get to the fully sort of blue area until when we've actually hit the UK. So to me, this suggests the possibility of a long sort of transition period where the storm is not fully extratropical. So according to this, the UKMO model, this actually shows that the storm could well still be tropical when it landfalls in the UK. And then we've got this one as well. This one is even more convincing because you can see, so we started off here at A, we became a deep warm core here, and then I think, I don't know exactly how these lines are going, but I'm assuming they're sort of doing this sort of path here. This one's even more convincing because we stay in the deep warm core right until the end where we sort of the transition is quite close to the UK. Actually, of the three parameters on the UKMO, two of them are the upper and lower thermal wind are favourable for this to stay a tropical cyclone, and only the symmetry parameter is unfavourable. But you can see that the symmetry parameter is low, so it's not like it's up here or anything. It's still quite symmetrical. And the thing you have to bear in mind about the symmetry parameter is that the cyclone phase spaces will average over the entire storm, and they'll use like a box, and then they'll sort of work out the symmetry within that box. But remember, I mentioned that these storms are small, high latitude storms are small. But this box is going to be the same for all tropical cyclones, including the bigger ones further south. So the box is going to be quite big, and the storm is going to be quite small. That means that everything in the entire box is going to be averaged. Now, it's quite possible that this appears to be asymmetrical, when in fact it is actually symmetrical. It's just that everything outside of the actual tropical storm is still within this box. So it's still averaging that. And you can see even despite that, we're still quite close to this red zone. And we can actually see that we're actually going down at this point. You can see here, actually, the other thing that's interesting is that you can see here that we've got this period where we're weakening, hence the poor satellite presentation here. And then we're sort of strengthening here. You can see the red colours are coming back. Yeah, so that I reckon that's why we're in the pink zone rather than in the red zone. I think if you account for the fact that these storms are small, we probably would be in the red zone. So based on that, I would say this is a very favourable forecast for for keeping tropical status. Maybe not quite at UK landfall, because you can see we have to go a little bit further. I mean, Cornwall is closer, so ideally, I guess you'd want it to go for Cornwall to actually maintain that status. But no, this is very favourable. While I'm here, I will talk a little bit about sea surface temperatures, as you can see here. So the number that's usually quoted is 26.5, which is I think it's this. Is it this line? That's 26, isn't it? So about sort of here, and this is where we are now. And you can see the sea surface temperatures are actually going to increase a little bit. So we're actually above the threshold for that. Now you can see here that we've got intensification, but the sea surface temperatures are dropped below the threshold. So how can that be? So I've talked about this a lot before. I think sea surface temperatures are problematic in some sense. They work quite well for lower latitudes. The reason that they work quite well for lower latitudes is because tropical cyclones are fueled by a temperature differential between the bottom of the atmosphere and the top of the atmosphere. By the top of the atmosphere, I'm talking about the upper troposphere, the lower stratosphere, that sort of height. In the tropics, the temperature in the upper troposphere, lower stratosphere, is essentially constant. It doesn't change. The fact that it doesn't change means that you can basically ignore it and just say, well, the temperature differential is going to be determined by what's going on at the bottom, because the top doesn't change. So higher top means higher bottom means higher temperature differential. The difficulty is that when you get into these northern latitudes, the top does start to change. So the top, so at these sorts of latitudes, the further north you go, the colder the top gets. Now, when you're in the lower latitudes, going north a little bit will not change much about what's going on in the upper atmosphere, but here it really does. Here it makes a massive difference. So yes, it's true that the bottom is cooling, but it's also true that the top is cooling. So if the bottom and the top both cool at the same rate, then the temperature differential is not actually decreasing. Hence, you don't actually need to have these high sea surface temperatures. Now, again, this principle is different in the low latitudes when your top is essentially constant. So you do need high sea surface temperatures in low latitudes. But as long as the top decreases, then you don't need your high sea surface temperatures. I mean, I'll see if I can try and illustrate this by looking at, let's just look at the GFS, for example, put it on Northern Hemisphere. So can we get 500 millibar temperatures here? Here we go, temperature, 500 millibars. Now you can see, this is the temperature sort of at the top, as I was describing. Down here, you can see where all the tropics are. You can see it doesn't change much. There's a little bit of variation, but you can see that there's a cooler patch here, and you actually get warmer as you go north. There's not much variation, but you can see up here there's a hell of a lot of variation. It's warm down here, it's cold up here. This is the point I'm trying to make, that the temperature at the top is going to be cooling down. Okay, actually, you can see there's a typhoon here. That kind of sort of helps illustrate my point. You can see that the entire environment is pretty much constant in terms of what's going on at the top. So sea surface temperatures are not to be relied on at northern latitudes. So actually, I will try and prove this. Tropical Storm Grace. An example of hang on, Tropical Storm Grace. I've got the right one. 2009 we want. Here we go. Tropical Cyclone Grace. Choosing this example because you can see this is the one that got pretty damn close to the UK. Didn't make a landfall, but still, this is essentially the one that we have to beat in order to break this record, so to speak. So if we look at the temperatures, I think it'll probably say here. Okay, by the time the storm was over 18 degrees. So again, I guess that was even too cold for the tropical cyclone. But you can see that it was still tropical in waters of 18 degrees. So 26 is considered to be the sort of standard. So we're talking about temperatures that were 8 degrees too low. Now, there's never, ever been a situation where a tropical cyclone at lower latitudes has survived at 18 degrees. I mean, I bet there hasn't even been a case where it's survived at like 23 degrees. So you can see how the point is quite well illustrated here. Another point that I often bring up is the whole Mediterranean thing. So the Mediterranean are sort of like these subtropical type systems that occur in the Mediterranean. The water temperature can be 15 degrees and these things can still be supported. It's the same principle. So don't get bogged down in the sea surface temperatures. The important thing to look at is the wind shear. If the environmental wind shear stays low, then we can delay the transition. Okay, have I talked about everything I can think of? I think just about. Yeah, so that's more or less it. It will be very interesting to track this storm as it moves further north. So we're expecting the storm to weaken maybe over the next 24 hours, then a period of intensification. Maybe we can get back to category 1. And then the transition will begin sort of by Tuesday. We can maybe possibly expect, if not a UK landfall, then maybe a transition before landfall. Either way, it's going to be really interesting and fascinating to keep watching this. So I think that's about it. Thanks everyone for watching. I think I'm pretty much done. Leave any comments you want below. I'll be happy to sort of clarify any points I've been making here. If you've just joined us, feel free to watch this video. It'll be available on demand. I think it takes typically 10 minutes for the thing to show on my YouTube channel. But yes, I don't think we will have a European landfall, but I think there's a genuine possibility of it happening. So this is just a challenge. The whole sort of it's completely impossible for a hurricane to ever hit the UK narrative, and sort of changing this, adding some nuance to this. That yes, it's unbelievably unlikely and probably a once in a lifetime, probably a 1 in 200 year experience. But let's not call it impossible, because I don't think the evidence suggests that it is impossible. I like to say, look how close this thing got. This thing got here. Is it really so much of a stretch that if one can get here, it can also get here? I don't think it is. I think it's possible. I think the stars have to be completely aligned. Everything has to go exactly right. I think all these things happen. Now, of course, getting a hurricane, we also need to not only meet this tropical definition, but we also have to have 74-mile-per-hour wind speeds. Maybe a bit less likely, but actually getting something tropical in the UK, I don't think it's impossible. Just unbelievably unlikely. Okay. So that about sums it up. Thanks for watching. Leave a comment below. Thanks.